Lab 1, Charge Tapes, Physics 2212, by me. Introduction. The purpose of this lab is to create two pieces of charge tape, then measure the charge on the tape. I created two charged U-tapes, then balanced them until the electric force from the bottom tape on the top tape was equal to the gravitational force on the top tape. I used this to calculate the excess charge in both tapes. This is my model. We have the top tape is experiencing both an electric force and a gravitational force from the bottom tape. So the bottom tape is a point charge which creates an electric field, which is calculated by the equation below, to produce an electric force, which is calculated 1/4 pi epsilon naught Q1, Q2, which are the charges of the two tapes, over r squared, which is the distance between the tapes, r hat, which is the direction of the vector from the bottom tape to the top tape. So the bottom tape creates a point charge, which creates that electric force, and then that's balanced by the gravitational force Fg equals mg from physics 1. So in the experiment, the system and surroundings, the system was the charge tapes, and the surroundings were the table, the air, and the mounting devices for the tapes. The initial conditions, the length of each tape was 20 cm, the width of each tape was 2 cm, the mass of each tape was 0.0002 kilograms, and then the distance between the tapes was measured to be 1.5 cm at equilibrium. So in the experiment, I created two charged U-tapes by rapidly pulling uncharged tapes off a base tape, which charged the U-tape through friction charging. I then held one tape on the ends of two stands and floated the second tape under it until the electric force repelled the top tape equal to the gravitational force on the top tape. So the two tapes were at equilibrium. Then I recorded distance between the forces and used that to calculate the excess charge on the tapes, the number of deficient electrons on the tapes, and the ratio of deficient electrons to atoms. So this is my code. I calculate, above this is a bunch of constants and setting up the objects, but these are the actual calculations. I calculated Fg is the mass of the tape times g, and then F equals Fg because they're at equilibrium. Then Q tape is the calculation of charge from the force, so it's just in like we want the charge and we have the force, so we just reverse the force equation. And then I just set some charges on the tapes, and then I printed the charge of the tape is Q tape. And then for the number of electrons, I just divided the charge on the tape by the charge of one proton. So we get the number of deficient electrons. And then for the ratio, I have the number of atoms. And then I looked up 1 times 10 to the 21st is the number of atoms per square meter of tape specifically. Then the ratio is the number of deficient electrons to the number of atoms. And so the numbers below is what I've calculated for my model. The modeled magnitude of the charge on one tape is 7 times 10 to the negative 9th, and my calculated magnitude was 6.3 times 10 to the 9th, which is pretty close. This is calculated by hand, so some errors could be I calculated it wrong, and like I measured wrong, and so it just comes out very slightly differently. And then assumptions include treating a long tape as a point charge and assuming each tape had the same charge. And we do this just because it makes the model significantly easier. If electrons had positive charge and protons had negative charge, the only thing that would change the sign of the observations, but the tapes would still repel because the experiment only relies that they have the same charge to balance the electric force with the gravitational force. And it's important to handle the charge tapes as little as possible because they can transfer charge onto uncharged objects, and we need two charge tapes. So in conclusion, I analyzed the forces acting on one charge tape in equilibrium, calculated its charge, number of deficient electrons, and ratio of deficient electrons to atoms. I then coded a model to calculate each of these things and compared them to my hand calculations.